So today we're going to learn about clippers and clampers. Now Harold put this tutorial together and he did a great job. It's a written tutorial on CircuitBread.com and I highly recommend you go check it out. He goes into the details with the math and all of that sort of jazz. But today on this video, I want to show some of those clippers that he describes in action. So here I have a setup with my very simple circuit, and it is hooked up to a waveform generator and an oscilloscope, and I'm using both channels of the oscilloscope to show the output of the generator and then also show what happens across the load with these different circuits. So there's a whole lot of connections here. You've got 3 grounds here for the 2 channels on the oscilloscope and 1 for the waveform generator. And then I'm measuring across the load, and then I'm measuring across the entire thing. And then of course the waveform generator itself is going in. So it's kind of funny to me that I only have 2 components on here and 6 things hooked to them, but that's how it is. So this first thing that we have is what we call a negative series clipper. And so this clips the signal that's coming in. And so what I have here is a 60 hertz, because that's generally, we're dealing with wall frequency, so 50, 60 hertz. So I have a 60 hertz input, and I can't do 120 volts output on this, so I'm just doing 10 volts. And then I'm showing what it looks like on this. So on the oscilloscope, you'll see the yellow is what is being measured across the load, and the blue is the output from the waveform generator. So you can see we have 5 volts per division. So we've got 10 volts up and down there. So if I turn off channel 2, or the input, you can see very clearly that we just have flat line, boop, flat line, boop. And if you've looked at any of our other tutorials, particularly on the half-wave rectifier, you'll be like, hey, that's just a half-wave rectifier, and you would be right. And that is what the first negative series clipper looks like. So now to do a positive series clipper, all we have to do is switch this diode around and put it in the other direction. So let me do that really quick. Okay, so I just set it up. All I did was flip the diode around, and I hooked everything back up, and you can see that my oscilloscope's going crazy, and that is because my trigger is at the wrong spot now. So I need to trigger it down there. And so it looks exactly like the positive series clipper, but now it's upside down, and all we're getting is the negative cycle on the bottom. So let's turn that back on. So again, this is what the input is, and that's what the output is. And you can see there's not going to be an exact overlap. One, just because I don't have this set up super fantastic, but also because there is going to be the slightest voltage drop across the diode. So you can see the input is all the way giving me a nice beautiful sine wave, but then my output, it's clipping the top off instead of the bottom. And so that's what you get with a positive series clipper. So now let's go to the next thing, which is the biased series clipper. So up until this point, we've been assuming that the average is 0. And so if we were to have an op amp or something, some sort of adder or some sort of DC offset in our circuit, we would see a shift. So I'm going to flip this diode back around, and I'm going to fake that DC offset with my waveform generator. So let's do that really quick. Okay, so now I have flipped the diode back, and we are back in a negative series clipper circuit. And you can see I haven't done the offset yet. So we have our typical output, but let me go over here and change the offset. And I really hope that you have access to these tools either at school or at work or something like that, so you can go over and you can do this exact same thing in your own space. And also, again, Harold has even more advanced demonstrations of how to do this, of more advanced clippers and clampers. So if you have access to this, I highly recommend hands-on and seeing it for yourself, because videos are great, but there's nothing like hands-on experience. So hopefully you can do that. But coming back to this, we have our 60 hertz, 10 volts peak to peak, and 0 offset right now. But now let's start to give myself an offset. So I have a 2 volt offset, 3 volt. And as you see, everything's getting shifted up, and so is this. So you're still getting that beautiful sine wave, and it's just clipping it lower and lower at that 0 point. So let me go up a little bit more. If you bias it enough, which that's the max for my arbitrary waveform generator, you can see it's almost a perfect sine wave, but completely above the 0 point. And then if we bias it in the other direction and get a negative voltage, then even less comes up. And now we're getting below the trigger point, so it's not even detecting it, but it's just getting smaller and smaller until there is nothing left, because at negative 5 volt DC, with a 10 volt peak to peak, the very peak of this sine wave is at 0. So of course you're not going to see it. So those are our positive and our negative series clippers with and without bias. Now let's move to parallel clippers. Okay, so our first parallel clipper is set up now, and really the biggest thing you can notice here is that the diode is in parallel with the load. So if there's a voltage across the diode, there's going to be a voltage across the load. If there's not a voltage across the diode, there's not going to be a voltage across the load. So in this one, I have the cathode hooked up to ground, and so when it is being forward biased, there is basically there's a 0.7 volt drop, and if we assume diode is ideal, there is no voltage across that. So if there's no voltage across the diode, then there's going to be no voltage across the load. So we come over here, and I need to set my trigger down here again, but we can see that this is when it is forward biased because there's no voltage across this diode. But when it's being reverse biased, that is when you get that negative dip. So let's switch this around, and you can take a brief second while I'm switching this to think of what exactly you think this is going to look like when it's in the parallel configuration, when the cathode is on the positive side. Okay, now as I'm sure you figured out, we're basically seeing the other side. We just inverted it. And this is one of those things, if you're doing it in series or in parallel, the way you have the diode, it kind of flips your understanding, because now instead of measuring the voltage on the other side of the diode, you're measuring the voltage across the diode. And so depending on what you need to do, depending on what you want to do, you can either do the series or parallel configuration for a clipper circuit. Now let's just bias this really quick. There shouldn't be any surprises here either, and then we'll go on to our clamper example. So make sure I'm on my offset. Yep. So it acts just like you would expect with the other one, with the series. So as you bias it up, you're going to see more. It's going to still retain that shape of the sine wave. It's just going to clip off certain sections. Clipper, clip off. Yep, that's where we're going with that. And then if I reverse bias it, it's just going to go away. Now the interesting thing is, if you notice earlier with the series, we weren't able to get the very bottom tip of this, whereas we were able to completely hide it, whereas you can still see little divots here. So that is because we are putting that 0.7 volt drop somewhere else in the circuit, and so you see a little bit of a shift there. Okay, so let's put together the clamper. All right, so I just finally set it up as a clamper, and as you can see, you have a capacitor that is in series with a diode and a resistor that are in parallel. And that's something you can see on the schematic, and I'm measuring over the resistor as the load, and also over the entire thing. So let's look at the oscilloscope here. I have it 10 volts peak to peak at about 1,000 hertz. I had to change out the value of my resistor. It is a 100K resistor, and now I have a 0.1 microfarad capacitor in here. And so as we look at the original, what's coming in, let me get that. You can see that being a 10 volt peak to peak, you get a 5 volt jump, and then a negative 5 volts, plus 5 volts, negative 5 volts. Now, as we turn the output back on, basically what we're getting is we're getting 0 volts, negative 10 volts, 0 volts, negative 10 volts. So we're shifting that peak, basically just taking our entire waveform and shifting it down 5 volts. And so it's an interesting thing, because we're not gaining anything here. It's not like we're getting an extra 5 volts, because we're stealing it off the top here. We're stealing it up here, and we're just putting it down there. And so you're seeing a little bit of a curve there. That's because of the time constant of the capacitor starting to discharge before it jumps again. So that's, again, where we're getting those RC discharges there. But a clamper, that's what a clamper does. It'll take your entire circuit and shift the voltage one direction or another. And again, you don't get anything free. It's not like you get a bigger voltage, you're just shifting it down, or in this case, but if you switch it also, you can go up. And that's it. Okay, so we've gone over clippers, we've gone over one variety of clampers. Again, Harold has a fantastic written tutorial on this sort of stuff with a couple of more demonstrations and a lot more math and a lot more in depth. I just wanted to show you what happens practically when you have these things and what it looks like on an oscilloscope, so that hopefully it can sit in your brain a little bit more intuitively before you jump into Harold's tutorial. I hope you enjoyed this video. If you did, give it a like, subscribe to our channel, and we will catch you in the next one.